Okay, so for number 5, it said to find the least common multiple of 30 and 75. We will also find the greatest common factor just so that you can see both of them and the differences in them. But least common multiple, I noticed, is what we need to focus on. I'm going to do this LCM in blue, okay? So we have 30 and we have 75, okay? So to get to 30, you can multiply 10 times 3. 3 is prime, 10 is not. We would have to multiply 5 times 2 to get to 10, where both of those are prime. Now to get to 75, we have to multiply 15 times 5. Keep breaking 15 down. 5 is prime. 15 we can multiply 5 times 3. And then circle out these two because they are prime. Now let's see what we've got here, okay? We've got for 30 and for 75. What I like to do is I like to start out with what has the smaller number, okay, out of all of them. 30 has the smallest number, and that is 2, so let's start there, and then the next one will be 3 for the 30, and then 5 for the 30. Okay, now let's look at what 75 has. We have a 3 and 2 5s. So I like to line up that 3 if something's going to line up. Those 5s are lining up, and then we have an extra 5 out here. We're going to circle what is in common. Okay? And then, so we have the 3 and the 5 in common. For the LCM, we will still use what is not in common. But the reason I circle what is in common is because I remember that when we go to multiply, I'm just using those common pairs one time. So even though I have, you know, two 3s here, being that it's in common, we're just using it once. And the same goes for 5. Yes, I circled 2 5s, but I'm only going to use it once. So now for the LCM, the least common multiple, we will multiply all of them, okay? We don't multiply 2 times 3 times 3 times 5 times 5 times 5. No, that's the point of me circling these, and remember that we just use it one time. So when we do that, we have 2 times 3 times 5 times 5, okay? So what you can also do is kind of cross this out then when we put that single digit above it, okay? So we have 2 times 3 times 5 times 5. Now 2 times 3 is 6, okay? And then 6 times this next number here is 5. So 6 times 5 is 30. Okay, now 30, since we're there at 30, times 5. Let's figure that out. 30 times 5. 5 times 0 is 0. 5 times 3 is 15. Okay, so our least common multiple is 150. Now let's keep this here and look at how we find the GCF, okay? Let's say that we already went through and we found our factors, okay? So we already went through this step of finding our factors. We used our prime trees. We're using the same numbers so we can look at the same factor trees, okay? Now let's go ahead and see again. I didn't have to erase that, but I did. We have, for 30, we have 2, 3, and 5 in order. And for 75, we have 3, 5, and 5. Try to keep them lined up. Okay? Now, what is in common? For the greatest common factor, that is all we will use, is what is in common, okay? And we're not worried about what is not in common, okay? So we're not worried about that. When we circle these, again, that makes it one time, okay, that we're going to use it. So even though we circled 2 3s, we're only going to use that 3 one time. You can kind of cross it out however you want to do it. Even though we circled these 2 5s that are in common, we're just using that one time. So now what are we left with? We're not using what isn't in common, and we're only using what is in common one time, if it's only circled once, of course. So we just use 3 times 5. Again, it wouldn't be 3 times 3 times 5 times 5. Yes, those are in common, but when we line them above each other and we circle these like that, like so, we're just using that number one time. Okay, so then we're left with 3 times 5. Well, our greatest common factor is 15, okay? So our LCM was 150. Our greatest common factor is smaller than that. Because of the word divide in the definition, we are at a smaller number of 15. All right, so now let's go over number 6. Okay, so number 6, I asked you to find the greatest common factor and LCM of 25 and 120. All right, so we're going to do it opposite of last time. This time we're first going to find the greatest common factor. Greatest common factor, let's use that factor tree method of 25, 120. All right, let's use our factor trees to break this down. To get to 25, I can multiply 5 times 5. Both of those are prime. Okay, now to get to 20, I can multiply 12 times 10. Both of these must still be broken down some more. To get to 10, I can do 5 times 2, where both of those are prime. Okay, now to get to 12, and I believe this may have been where you messed up. I noticed you left 2 and 6, and you left 6 without being broken down. Well, 6 is not prime because it can be multiplied by 2 numbers, and we can get there, right? We can multiply 3 times 2 to get to 6, but we can't multiply, you know, anything without using a 1 to get to 3 or 2 or 5. That's why those numbers are prime and 6 is not. All right, so we are again finding the greatest common factor. Let's list what we have. We have 25, we have 120. Let's see what we have. For 25, or being that 120 has smaller numbers than 25, I like to start there. So we start as small as possible. What's the smallest possible? Well, we have 2's here, so let's start with those 2's. Let's line them up. 2, 2, 2. Then we have a 3 and a 5. Oh, I kind of ran out of room. Bear with me here. 3 and 5, right? 2, 2, 2, 3 and 5. Now for 25, we just have 5 and 5. Okay, so we're finding the greatest common factor. Think to yourself right quick. Will we use just what's in common, or will we use what is in common and what is not in common, aka all of them? For the greatest common factor, you only use what is in common, okay? And all we have in common, as we can see from this lineup, is 5. So 5 and nothing else in common, well then our greatest common factor is 5, okay? So, oh, this should have said number 6. That might have been bothering you the whole time. I know it would bother me. Okay, so now we know that the greatest common factor is 5 of these numbers, okay? Oh, I should have left this. Let me leave this. Okay, because we can use the same thing to find the LCM. All right, so we're finding the least common multiple now. Now, I know this is where I gave you some problems. Say you went through, you found the factor tree. We're using the same pair of numbers, so we know our multiples already, okay? So we're at 25, 120. Everything is still the same, even this part. We had 2, 2, 2, 3, and 5, and then here we had 5 and 5. Now circle what is common, because we know that instead of using those 2 numbers, we're only going to use it once. That's all that's telling us. But now we still have 2, 2, 2, 3, 5, and 5, okay? So instead of using this 5 2 times, being that it's in common, we're only going to use it 1 time, okay? So that's where that 5 comes from, that one single 5, all right? So you're going to multiply 2 times 2 times 2 times 3 times 5 times 5. Okay? And when you do that, we know that 2 times 2 is 4. 4 times 2 is 8. We've used all these. 8 times 3 is 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay? We have used this one. Now 24 times 5, let's figure that out. 24 times 5. 5 times 4 is 20. Put your 2, or carry your 2. 5 times 2 is 10 plus 2 is 12. Okay, so 120, we have used that 5. Now we have 120 times 5. So let's see, 120 times 5. 5 times 0 is 0. 5 times 2 is 10. Carry your 1. 5 times 1 is 5 plus 1 is 600. So we know our LCM equals 600 as opposed to our greatest common factor, which was 5. It's a big difference. So learning how to differentiate the two is important. And I just want to focus right here again one more time because I feel like this is really maybe where people go wrong. Okay, so let's list our factors again. Like let's say we didn't do these, okay? But we're here at the end at our prime numbers, and let's list them again. I know I erased it and it's going to be the same thing, but that's okay. Okay, we had 2, 2, 2, 3, and a 5. Okay, 2, 2, 2, 3, and a 5. Okay, now for 25, we just had 5 and 5. Okay, so 5 and 5. Okay, we have nothing common here, nothing common here, nothing common here. 5 and 3 are not common. 5 and 5 are common. And when they are common, we just remember to use them as 1 5. Okay, so instead of 2 5s, this goes away and we're only going to use them as 1 5. Okay, so then that leaves us with what we had. 2 times 2 times 2 times 3 times this 1 5 that wasn't common, and then this 1 5 that represents this common pair, right? Okay, and that's how we got 600 when we multiply all these. Now, had we just went ahead and multiplied all of them, and let's see, we had a 5 here and a 5 here, well, rather than it equaling 600, which is the correct answer, let's see what it would bring us to. 3 times. So that would basically be like us having 3 5s, which again, this is incorrect because we were supposed to exit this out and only use it as once. But let's see the wrong case scenario. So this will be 4. 4 times 2 would be 8. 8 times 3 here would be 24. And then 24 times 5. I know we just did that one. Okay, so that would be 120. So then 120 times 5, that would be the 600. Okay, so this would be 600 here. Now, that would be like us multiplying this last 5 to it, okay? And that would bring us to 5 times 6 is 30. That would bring us to 3,000. So it is definitely important to remember when you have this common one, you look at it and say, okay, yes, I see 2 numbers, but I only use that number 1 time when I'm going to multiply. Okay, so that's the least common multiple. You'll get a larger number every time if you are looking for both the GCF and the LCM. The LCM will definitely be your larger number.